Okay, exercise 3B, question 7F. Now, I'll try and do this question quickly. Had somebody ask about this question, so that's why I wanted to do it as a video. And let me just try and say the words that I'm thinking. The words I'm thinking are, what I did was I graphed it right from the start. Now you can see here I've got something else in there, but it's not selected. So I've gone down to the second spot. I've written E minus X. There's your X button. Divide X. I've done a zoom standard. That gives 10 tens. It doesn't graph the asymptotes very nicely, but you can see from here, let's see if my pen will work. This question's asking about increasing, decreasing. You want to do a sign diagram in this question, but I can actually do the question right now. Right? Just from the graph. I could say, well, that's -1, yeah? -1. It's increasing, then it's decreasing. We have a local max here, and I could find it using second calc maximum, right? There's an asymptote coming through there right on the axis where x equals 0. We draw it in like this. Okay, we're decreasing on that side of the asymptote. And on this side of the asymptote, we're decreasing as well. Right? So we'd have a minus there. I'd label it. It's the first derivative showing gradients. Positive gradient, negative gradient, negative gradient. Done. Question, well, I think the question you had to say increasing, f of x is increasing when x is smaller than or equal to -1. We are decreasing, so f of x decreasing when x lies between 0 and -1, and when x, maybe do a comma or something, and when x is greater than 0. Now, what the book does is, if you're on an asymptote, makes sense, don't say smaller than or equal to, or greater than or equal to, because the function cannot exist. But about stationary points, we're going to use the smaller than or equal to, if you follow what the book does. Okay, I guess that's valid, but let's do it without the graph. So we'll go back, we'll erase this, and we'll start again. Okay. So I'd actually rewrite this function, I think. E to the minus x times x to the -1, so that I can apply product rule. I've got function u times function v. Now you can use quotient rule if you like, that's fine. Quotient rule or product rule. I can see a couple of different ways. When my quotients are a bit simpler, I tend to go for product rule. But I don't know, maybe try it both ways, see which one you like. X minus 1 minus x minus 2. So the derivative, we get OOV. There's our first OOV would be -1. Now what I'm looking for is these negative powers here. So negative powers, we're taking the reciprocal, we're putting these on the bottom of fractions. we've still got a minus there. It's nothing else, so it's a minus 1. And product rule says we have to plus, but I can see a minus there. So minus, looking for negative powers. So they're going on the bottom of fractions. I've got an x squared from there, and I've got an e to the x from there. All right. To draw the sign diagram, I need to know when this equals 0. However, what I should have said, and what you should be on the lookout for, is asymptotes. You can see them before you even start. Right, going back to this original function, maybe I make a note or something. Nota bene, x could not be 0. I can see it before I start. That x can't be 0, can't divide by 0. Right? So that's going to be an asymptote line in the sign diagram, no matter what happens here. Right? Now, we make this equal to 0. There's two ways you can do it. You can go for your common denominator, x squared e to the x. All right, there's your common denominator there, because you just have to times this one by x to get minus x minus 1. How do you make that equal 0 when the top equals 0? This is the best way to do it for this question, I think, because this is working out fairly easy. Plus x to both sides, we get that, and we've just found our point. Let's look at the graph again. So that's at a minus 1, right? Here's your max. Now, hang on, back to this. If you like, you could say, all right, that derivative there, I could say it equals 0 when, when this thing here equals 0. And what I could do is add that term to both sides. I could say when minus 1 on exx, I think it'll end up being a little bit more work, but just showing you another way to get to this point. So times both sides. You can do that in one step. So times both sides by e to the x on x, and times both sides by x squared e to the x. You get your cross multiply step. E to the x, subtract that from both sides. Equals 0. Do a factorization. What have we got? Minus x e to the x. I'm left with an x from there. I can divide all that by minus x e to the x. It will be a plus 1 equals 0. Therefore, there's a solution in here, x equals minus 1. I think this way was better this time. So this way we're just looking at the numerator. How do we make it 0? So how do we make the fraction 0 if the numerator is 0, right? Now, you might be looking at this and going, oh, x could be 0. But we already identified this asymptote. So that's an asymptotic point. You can see it here actually. Right? X can't equal 0. Right? And you can see it there and there in the derivative. Just wanted to, I've already done the sign diagram, so I won't do it again. And we've written the answer about increasing, decreasing functions. But if you were testing this, I think this might be a good question to use your calculator. So if you've got your first derivative, maybe if you factorize, what do we got here? Minus 1 on e to the x times x. I'm left with 1. It's going to be a plus 1 on x. So what I mean is, you know, we had a sine diagram. We had a 0 and a -1 on it. -1, that was our maximum. 0 was our asymptote. Now, so what we had plus, and I can't remember what was there. I can see it on the graph. Negative. Oh, we got, hang on, maximum, positive now. Ugh, I'm making mistakes, aren't I? I'm racing. That's positive. That is negative. And that's negative. Right, so you're coming down here. If you want to do these little sketches on the sine diagram, so there it is again. Right, these are x values. I'm graphing the first derivative, or sine diagram of first derivative. So label things properly, make it a bit neater than mine. But this is the point I'm trying to make here. So I want to do a test of the first derivative, and I want to put in, I don't know, some value in here maybe, -1/2. So in this region here, it might be a little bit hard to do it in your head. And so you might be better off going to a calculator for something like this. You do, you know, -1 on e to the -1/2 times -1/2. Now that bit there is positive, right? No matter what the x is, that's positive. So you can sort of ignore that in your brain. You know, if x is positive, obviously positive. If x is negative, we've got a small number, but it's not a negative number. If x is 0, we've got 1. If x is 1/2, we've got a square root. So that is never negative, right? What we end up with there is a negative divided by a negative, which is a positive. And we'd have 1 plus 1 on -1/2. So 1, so this is a negative number. 1, how many halves is 2, and it's -2. So you have 1, so that's negative, that's positive. So you get positive times negative is negative, right? But I'm just thinking, when the functions get a little bit complex like this, you may want to just put them into your calculator. So if I just leave this here, just to show you, show you me doing that, so I can show myself doing that to you, I would be writing -1 divided by brackets e, it's the second function, e power -1/2 minus 0.5 times -0.5 half, close the brackets. Yep, okay, so I've just put in that bit there, right? Open brackets. 1 plus 1 divide -1/2, close the brackets, press enter, and I'm looking for, can't even remember now, is it positive? No, it's a negative number. I should be getting a negative number, and I do, and that's all I care about. Don't care what the number is, just care it's negative. So I've just tested -1/2 on the graph. I've tested something in about there, and we're going downhill with a negative gradient, right? So that's how I would be doing those tests. For something a bit more complicated, I'm probably just going to go straight to the calculator to plug in. You don't have to show yourself doing this, but you do have to get the sine diagram done and correct. You need to be reading the question. This question needed the answer about increasing or decreasing. So I'd be saying a statement at the end, f of x is increasing, you know, and actually answering the question. You might have a question saying, classify the stationary points. You can see that's coming up here. Right, so I don't know, does the book show you? Does it? Let's have a look and see how they do it. They got an example. Yeah, they do. So it says, find the position and nature of a stationary point. All right, they've done the derivative, they've done their sign diagrams, and notice that the question didn't say to do a sign diagram, but it's a really good way to show or find that this stationary point will actually be a maximum, right? Because in the final answer, you need to write that. The stationary point is a maximum, right? Local maximum, because it might not be the highest value in the entire function. So we say local maximum, and then you give the entire point, right? So you take your 3, you put it back into the original function, all right? That'd be 3 minus 2 is 1, e to the minus 3, basically. So that's 1 on e to the 3, and they've written that in. Okay, thank you.